I am student of Sri Venkateswara College of Engineering, Bangalore. My name is A. Purnaseshan, Department of Information Science and Engineering, USN 1V22 IS001. Subject is ADA, Analysis and Design of Algorithms. Today, the main topic of our presentation is Fundamentals of Algorithmic Problem Solving. Let us see what exactly it is. Introduction to Algorithmic Problem Solving. Algorithmic problem solving involves designing a sequence of steps to solve a specific problem. It requires breaking down the problem into smaller subproblems. Algorithms are essential for efficient problem solving in various fields. Understanding the problem. Begin by understanding the problem statement and constraints. Identify the inputs, outputs, and any specific requirements. Clarify an ambiguities or uncertainties before proceeding with the solution. Designing an algorithm. Choose an appropriate algorithmic approach such as divide and conquer, dynamic programming, or greedy algorithms. Break down the problem into smaller manageable steps. Consider the time and space complexity of algorithm to ensure efficiency. Actually, algorithm is nothing but step-by-step process. Before going into the actual program, you need to create an algorithm that makes you understand what exactly the program is, what exactly the program it is. Pseudocode and flowcharts. After algorithm, the more another basic understandable form is pseudocode and flowcharts. Flowchart is nothing but graphical representation. Pseudocode gives the part of programming concept. Use pseudocodes to outline the logic of the algorithm in plain language. Create flowcharts to visually represent the steps and decision points in the algorithm. Pseudocode and flowcharts help in translating the algorithm into actual code. In the right side, you can see the diagram how exactly the flowchart works and looks. Implementing the algorithm. Translate the pseudocode or flowchart into a programming language. Test the algorithm with different inputs to ensure it produces the correct outputs. Debug and refine the algorithm as needed to address any issues. In right side, you can see a simple program where you can find the sum and average of a given number or digit. Analyzing the algorithm. Evaluate the time complexity of algorithm to understand its efficiency. Consider factors like input size and resource requirements. Compare the algorithm with other approaches to determine its performance. Here you can see time complexity. Time complexity has three asymptotic notations: big O notation, big theta notation, and big omega notation. Based on that, we can find the time complexity of an algorithm. Optimizing the algorithm. Identify potential bottlenecks or inefficiency in the algorithm. Look for opportunities to optimize the algorithm by reducing redundant operations or improving data structures. Iteratively refine the algorithm to enhance its performance. Handling edge cases. Consider edge cases or corner cases that may not be covered by the initial algorithm. Test the algorithm with boundary inputs or extreme scenarios to ensure robustness. Modify the algorithm to handle edge cases or corner cases gracefully. Edge cases are basically the test cases which explore the boundaries of an application. The boundary may be based on the use case or based on technology. Based on use case, user clicks all the buttons on view. Based on technology, what is the behavior of the application on SQL based on 2000. Documenting the algorithm. Document the algorithm's logic, inputs, outputs, and any assumptions made. Provide clear explanations and examples to aid understanding for others. Maintain documentation for facilitate future modifications or troubleshooting. Conclusion. Finally, algorithmic problem solving is a systematic approach to solving complex problems efficiently. By understanding the fundamentals and following a structured process, one can develop effective algorithms. Continuous practice and learning are key to mastering algorithmic problem solving. These are the basic fundamentals of algorithmic approach. One programmer has to follow writing algorithm before starting or going into the problem. By writing algorithms, you can get the basic form or format, how does the program work and how it looks. Thank you.